Alright, hello, this is going to be Solidworks CSWA practice problem 10.4, and if you want to follow along with the video, make sure to follow the link in the description that will take you to the official Solidworks practice problem database. So let's get started. First of all, our units are going to be in MMGS, and we're going to start our base extrusion from the top, and we're going to draw the entire top view and just extrude it up, and then from there we're just going to do 1,000,000 revolves at the same time. This entire part can pretty much just be made from revolve cut alone. So first of all, we're drawing the top profile right now. So I'm going to use my mirror tool here. So let's draw a vertical center line. And I'm going to attach a point before I do anything. And this point is going to be the center point for every single arc, or this is going to be the very top of the part, and that distance is going to be 89. So it's fully defined, can't move. And then from here, I'm going to draw a diagonal line that goes into a straight line down. Then, a straight line down that goes horizontal into the origin, like this. Let's mirror down to the other side. Then let's give the diagonal line a dimension of 30 degrees. Oh, 30 degrees not from here, but from here, right? Those 30 degrees from this edge. Then let's give a width of 24 to the part. That should fully define it. And also, if you're wondering why in the drawing it doesn't have this corner, it's because you're gonna attach a fillet here later that's going to kind of cut out some of this material here. So that's why it's not connected. But you'll know it's connected because of those dotted lines that connect to this point from the kind of underside view. So anyway, we're going to extrude this, blind extrude this upwards by a height of 62. And we'll just select OK for now. So let's start our sketches for the revolve. So I'm going to start a sketch in the right plane. We're just going to cut right through the middle of everything. And I guess I'll start on the bottom. So I'm going to start with the corner rectangle on this side. So I'm going to start with the corner rectangle on this side. And the height of this rectangle is going to be 5. So it'll be like this. And the width of the rectangle should be 26. And why do I know it's 26? Oh, it's because this edge right here is vertical to the axis of revolution that we're going to use to revolve these sketches, cut these sketches. And then the distance from the first kind of arc extrusion on the bottom side is 26 away from that axis. So that gap is going to be 26. when we're talking about the rectangular revolve cut. So yeah, the arcs are kind of visualized into rectangles, so you kind of have to change your thinking in terms of that. So then from here, I'm going to add a smaller rectangle. So let's add some basic dimensions. So the distance between the two edges, inner edges, this gap is going to be 3. And this gap is going to represent what's left over, because these are cuts and this is what's left over. So this is going to be the kind of arc extrusion that's on the bottom side of the part. And then this rectangle's width should represent the gap between those arc extrusions. And the gap between the arc extrusions is 5. So this width should be 5. And of course it should have the same height as the previous rectangle, so we're just going to make the top collinear. And then we're just going to copy this over a couple of times, I believe 6 times. So I'm going to go to linear sketch pattern. I'm going to add a distance of 8 actually. And the reason I say 8 is because to get from this edge to the next same edge on the other instance, it would have to cross this width and then the gap. So 5 plus 3 is 8. So, and I want, I believe, 6 instances. And the entity will be this one. Let's swap the direction. So there's 6 gaps, which means how many arc extrusions do we have? We should end up with 7. So it's 1, 2, 3, 4, 5, 6, and then the 7th one will be right here. We'll need to create another rectangle here. So 6 gaps is good. So we'll leave it like that. And we just gotta add 1 dimension, and we'll just make it 3, just to define everything. And then here's your last rectangle. Make it like this. And you notice I'm extruding the rectangle kind of past this point. But the reason you need to do this is because if you think of the revolve, it's going to kind of cut downwards into like a circle, kind of like an arc pattern. But the thing is, if I were to begin the rectangle from this edge so that it's coincident instead, it would actually not go deep enough to get this corner right here. So it's going to leave this corner and it'll leave material. So you don't want that. You want to make sure it cuts everything, including both corners. But in this, on the right side rectangle, you didn't have to do that because the edge that it was coincident to, this edge, is already kind of the vertex of this kind of triangular part right here. So if you visualize it doing an arc cut on both sides, it's going to cut everything. But for here, you need to kind of add an extra bigger rectangle. So first of all, I'm going to make sure that the heights are coincident, or collinear, I mean. Oh. Collinear. And then the gap between these two should be 3 again. So that'll be your 7th arc extrusion. So you have 1, 2, 3, 4, 5, 6, and 7. And you just add like an arbitrary dimension here. I'll just say 20. And then those are your rectangular cuts. I guess I'll just cut those first. So I'm going to go to Features, Revolve Cuts. Oh right, I forgot to set my center line. So I'm going to get my center line. Let's put it right here along this edge. revolve cut, and there you go. Should be this huge mess right here. So you select OK, and then you should end up with all those arc extrusions there, all 7 of them. And I also cut out the entire bottom side too, because we made the rectangle extra long on the left side. So notice how there's no material here. So that's exactly what we want. So from here, we're going to go ahead and make the revolve cuts for the steps, for the curved face steps, and then the revolve cut triangles along those steps. So let's create another sketch, again in the right plane, which would cut right through the middle. Right plane. Here you go. Okay. So, let's see here. Okay, I guess I'll start with a straight line. Actually, you know what? No, I'll start from the top. I'll start from the top like this. So I'll go down, go across, go down, go across again, and then I'm going to draw another line. And it's important that you, well actually, first let me complete this and I'll explain it. So I'm going to finish the contour like this. Okay, so first of all, I already explained this in the previous one, but the reason we kind of protrude this sketch beyond the edge is so that it can cut the corners as well, because it's going to kind of arc down and cut, so you need to accommodate for that. But then the second thing I want to take a look at is this line. Notice how I drew 2 different lines, and I could have just drawn one line across, but then the problem with that is my midpoint gets screwed up. So I want this line to be coincident with this edge, so that my midpoint is perfectly in the middle right here. And why does the midpoint matter? It's because that's how I'm going to locate the triangular revolve cuts. So first we're going to dimension these, and we'll get the triangles in. So the distance between this edge and the right side edge is 36. The length of the first step is 24. The length of the last step is 24. Let me see. $36, $24, $24, $29. Oh, I see. Wait, do I see? Yes, I think I need to do something else before I make these dimensions. So I'm going to go ahead and exit my sketch here. And I think we need to make some fillets on this corner, this triangular corner right here. So I'm going to go to Features, Fillets, and I'm going to add 3 fillets, or actually 5 fillets. So I'm going to add 5 R5 fillets, and one of them will be here. The other one is right here on this edge. Another one right here. And then the other two are on these two edges. So I'm going to do one here. Oh, not that, not the whole face. Do not want that. I'm going to do one on this edge, then on this edge. So that should be all your fillets. Select OK. And then, yeah, from there we should be good. Okay, so I'm going to go back to the sketch. So I'm going to delete this dimension. Oh. Oh, I guess this sketch was made before the fillet, so I need to delete this sketch. So let's start that sketch again. Now that we have like the shortened version of the part, let's start that sketch again in the right plane. So let's make those steps again. Then the protruding part. And then now let's add those dimensions back. So the distance between this and this edge will be 36. This higher step length is 24, and then this last step should automatically be 24. Yeah, so the dimensions given in the section BB view are actually the dimensions that you're supposed to use after you make these fillets, not before you make these fillets when you have like the sharp corner. You make the fillets first and then do these dimensions. So now the heights. So the height of the first step is going to be 16. And then the height of the second step is also going to be 16. So it'll be like this. Then, oh, I guess that, yeah, I'll just add an arbitrary distance between this edge and the left edge. I guess I'll just make this 18, and that'll be fully defined. Okay, so this is going to be revolve cut around so that we can get our arced face steps, but we still need to get our triangles, 4 of them. So I'm going to draw some triangles. Yeah, I think the easiest way to do this is going to be to start off with a horizontal line, then make 2 diagonal lines that are perpendicular to each other, like this. And then I'm going to look at detail view C for my angles. Well, I'm actually just gonna, yeah, I can just make these perpendicular. So I'm gonna just control click both these ends, make perpendicular. At a 90-degree angle. Ah, I see. Actually, you know what? I think it'll be easier if we just do something else. I think I'm just gonna make center lines at the midpoints, and then I'm just gonna use the mirror tool to automatically create symmetry, right? So I'm gonna center line here. I'm gonna center line at every single midpoint that I find along the steps. So let's add a center line here. Oh, the center line is actually not fixed with the midpoint. Let me fix that. So I'll make these coincident. Add a center line on this midpoint, like this. And my last center line will be on this midpoint, like this. And we're going to do a repetitive process of making all the triangles. So I'll start with diagonal line, then we'll mirror it. We'll cap it off. And now since those diagonal lines are mirrored and symmetric, if I add an angle, they'll kind of be equally, they'll have equal angles from the center line. And I just need to get the height, which is just 1.5, and it's fully defined. So we're going to repeat that process for 4 more times. So diagonal, mirror, cap, angle, then height. So mirror, cap, then angle with its height, and finally so mirror, cap, angle, and height. Okay, finally. So let's revolve all this. Let's get our base parts finally. So we go to, oh actually, hold on. Oh yeah, I lost my center line. I need to draw another center line. So the center line, well, you need to remember that, remember the center line was coincident with the sharp corner, but now that it's rounded, it's a little shorter, right? So we need to kind of manually find the distance. So I'm gonna draw a vertical center line. And if you remember, the distance of the axis of revolution from the origin was 89. 89. So let's revolve cut all this. So let's go to feature, revolve cut, choose this as my axis of symmetry, and for my contours I'm going to select everything, including the triangles. 1, 2, 3, and 4. So that should be cutting everything. So I'll select OK. And then you have your 4 triangular revolve cuts. You have your kind of arc-faced steps, and they seem to be correct. So there's your base parts. So from here, we have one through cut to make, and then we'll have to mirror it, and then we'll end off with a couple of chamfers. So let's start with a through cut. So I'm going to start a sketch, this time on the front plane. Yes, front plane. And I'm going to prep my mirror since we need one cut on each side. So, yes, okay. So if you, actually I want to use another mirror tool again. So if you look at the front view drawing, you'll see that the distance from this edge right here is going to be 8 from the first point that's used for the cut. But then if you look at detail view A, you'll see that the width of the cut from point to point on the open end is 8 millimeters. And I want to draw a center line to kind of mirror both sides to make it symmetric. So I'm going to add 8, but then I'm going to add 4 to that. So it'll be right in the middle of where the cut's supposed to be. So I'm going to horizontal center line. Its distance from this line will be 12 because it's 8 plus 4, and this is where I'm making my sketch. So it seems to be a line like this into, actually no, first I'm going to mirror that line. Then I'll cap it off on both ends. So now they're symmetric. Let's make sure the angle between them is 35. 35 going out into like the fat side. So 35. The distance between the two short side points is going to be 8. And then finally, its height is going to be 6. 6. But we're not done. We still need to put 2 fillets. There are 2 fillets. Both are 2 fillets. So I'm going to add one here, add one here. Select OK. And now, using this vertical center line I made earlier, I'm going to mirror this whole thing onto the other side. Now that we got both, I'm just going to do a through cut through everything. So extrude cut, through all, and there you go. So now we just got to finish this part off with some chamfers, and that should be it. So I'm going to go to Fillet, click chamfer, and it says there are 5 3mm chamfers. So I'm going to put 3 millimeters that are 45 degrees. And those chamfers are, wait, if there's 5 of them, 5 of them. How can there only be 5 chamfers? 5 chamfers. Oh, okay, I see. The reason it's 5 chamfers is because this one at the top is literally just 1 chamfer, right? Because using the tangent propagation tool, it detects any edge that's tangent to it, so it selects the whole thing. So this technically counts as 1 chamfer, even though it's getting multiple edges. That's why it says 5. So then I'll just, actually no, I'll keep going. So there's another So this is the second edge right here. So that's 2. And then on the opposite side, that's 3. And then same for this step, that's 4. And then finally, this is number 5. So we'll select OK. There's all of your chamfers. Let me double check just to make sure I'm not missing anything. Nope, everything seems in order. So I'm going to go check the answer now. So let's go to Evaluate, Mass Properties, and check the volume. For my volume, I am getting, let me see, 71,721 cubic millimeters for my volume. Say it again, 71,721 cubic millimeters for my volume. So I hope you learned something from this video, and I'll see you in the next one.